Hi folks, and welcome back to Math with Captain Rod. The purpose of this video is to demonstrate how to solve a first order differential equation with a given set of conditions here. So we're going to take a look at this example where ds dt is equal to cosine t plus sine t. And we're looking for where, or in addition to this criteria, s of pi has to be 1. So what we're looking for is s, some function of t, that satisfies both of these conditions. First, we'll start with our differential equation here. Now, this is a first derivative, which means it's separable. And that means you can multiply both sides by dt. So this is going to read ds equals cosine t plus sine t dt. And then this is solved by integration of both sides. Integral ds equals integral of cosine t plus sine t dt. Now, the integral of ds is s. And now, as we go through here, I'm going to integrate these term by term. Right? Antiderivative of cosine t is sine t, because the derivative of sine is cosine. Antiderivative of sine t is minus cosine t. Now, remember, the derivative of cosine is minus sine. But this is plus sine. That's why this minus sign is required, so that by the time you differentiate all of this, you end up with plus sine of t. Now, we do not have limits. Anytime you take an integral where you do not have limits, that introduces a constant. Technically, there's a constant on the left and on the right, but if I called the constant on the left C1, the constant on the right C2, you move C1 over to the right, you've got C2 minus C1, which is just some other constant. So long story short, when you integrate an equation like this, you only need to introduce one constant typically. So what we have here is we have a function s as a function of t. And what we have is really a family of functions, because I can at this point put any number I can think of, any real number in the entire universe in for that value of c, and it will solve this equation. Now we're going to look for the specific c that goes with this criteria. So when t is equal to pi, s has got to be equal to 1. So I'm going to go ahead and put a 1 here, equals sine of pi minus cosine of pi plus c. Now the sine of pi is 0, and the cosine of pi is minus 1. So this is 1 equals 1 plus c. So when we solve this for c, we get 0 out of it. Okay? So the solution of this equation is s equals sine t minus cosine t. This equation should satisfy both conditions. When you differentiate, we should get this. And when we put pi in for t, we should get 1 out for s. So hope this video helps demonstrate how to solve these equations. Have a great day.